Hello and welcome to part 5 of Dev Maths and Stats Refresher Course, Lecture 8. In this second demonstration we're looking at the covariance of random variables. So that means that how two random variables vary together or don't. So here we're looking at these two worksheets. So again, I really urge you to have a go at this, go through the steps, because it's your one and only chance really to look in detail at how the numbers actually relate to all these abstract formulas. So these are the things we're going to try and get formulas for. So at the end of this you should have a formula sheet with these on and also with the others that I had here. I just wanted to point out that we never did fill in that last one there. So these are the ones we're going to try and fill in during this section about the variance of two added together and so on. Down to these things which are the correlation coefficients. Look at properties of those. Oops. So we're on this one here. No. Oh, that's one. If you want to work through the variance thing again with a different probability distribution, that's recommended. And similarly, the covariance, there are two different ones with different properties. I'll just show you this fairly standard one. The rules work with both of them. So with this one, we're in a setup where we have two random variables, y and x, which can take these values. And here is the joint probability distribution. So here's the probability that x is 40 and y is 30 and so on. So you've got all the combinations here. This kind of gives you a clearer picture of the joint probabilities, but it's quite hard to do calculations based on this because you want to sum columns of numbers. So as I did with a shorter example on the lectures, just in the lecture just now, previous video, I've taken these and I put exactly the same information down here. So you've got all the combinations of x and y and the same probabilities. So you should be able to check that, like x is 30, y is 10, you get 0.127. So 30, 10. X is 30, y is 10, you get 0.127. No, you don't. You get 0.128. Oh, yes, it's here. X is 30, y is 10, you get that. 0.128, that's right. Okay, 0.028. Okay, yeah, these are the probabilities. This is the cumulative probability. So, sorry, this over here is the sum. So it's the probability of all the numbers up to that so far. Okay, so I think there's not much choice on this one because I have to keep flipping back to here because there are too many instructions to just copy across. So what I'm going to do is add in some columns for a start, which are x times p, y times p, and xy times p. Hopefully you can start seeing where this is going then, and then add these up. So this is going to be x times the probability, this is going to be y times the probability, this is going to be xy times the probability. So it's going to be x times the probability of that. This one's going to be y times the probability of that. And this one's going to be x times y times the probability. Press equals perhaps. It's going to be x times y times the probability. Okay, so let's just check that. That's that time. Gosh, some strange things going on here. Too quickly. That's that times that. That times that. That times that times that. Good. Once you've got them set up, there we go. Zoom down here. And I'm going to add these up. It's better. So I hope you're doing this. I hope you got the same totals here. What the totals show you, of course, is this is the expected value of x. Expected value of y. And that's expected value of xy. So what I will do is I'll just first check what it says on the sheet. What about the product of the other two? So if I get the expected value of x and I multiply it by the expected value of y and I compare it to the expected value of xy, I find they're not the same at all. Okay, so expected value of xy is not the same as the expected value of x times the expected value of y. But what you will do is just take these, and I will just do this on the next sheet. So I'm going to copy those ones we've added. Just go to here. We've got another very similar kind of situation with x and y defined by that distribution. If I paste in here, then it copies the formulas across, and now they refer to these distributions here. So we do the same, exactly the same operations, except let's change that. Here we find that here's the expected value of x, expected value of y, slightly different, expected value of xy. But here, the expected value of xy is equal to the expected value of x times the expected value of y. And that's actually because, in this case, x and y are independent. There's no dependency in terms of the probability of x is not affected by the outcome of y and vice versa. And a definition of that is that the expected value of xy must be equal to the expected value of x times the expected value of y. And you can compare that to the probabilities. If A and B are independent events, then probability of x and y is equal to probability of x times probability of y. Okay, but I think for the rest I'll leave this sheet because this is just showing the same things that they work for independent variables, but we'll just stick with the case when they're dependent. So that tells you that this only works when things are independent. Keep adding some columns. So here we're going to add these columns for the difference between x and its own expected value squared times probability, and the same thing for y. So it's a bit like what we did on the previous sheet. Actually, I'm going to also take a lesson from my own book, and at this point freeze those panes. Freeze the panes there, and also, because we don't really need this stuff at the top so much anymore, shrink this down a bit, maximize the screen value there. So that's horrible, isn't it? So get rid of that. Okay, so we can see what we're dealing with at the top. That's not going to work because we need that later. Let's just hide those. Sorry, whiz through this, it's getting boring. Right, so onwards and upwards. So here, we're working towards getting variances for these things. So we know the variance is going to need to have that, subtract its own mean value, local x mu, and then square it. Okay. And then it's going to be y subtract its own expected value and square that. Actually, I was going to do it all in one go and times by p as well, wasn't I? The previous spreadsheet did the same thing, except I did this and then multiplied by p in the next column. So let's just do it all in one go here. So we want the value of x, subtract expected value down here somewhere, expected value of x, which is at the bottom. I'm just going to freeze the row number on that. And then raise that to the power 2, and then multiply it by the probability, which is somewhere over here. So you can see what we've got here. That's the x, subtract the expected value, which is down at the bottom, raise to the power 2 and multiply by the probability. Oh, one more thing I need to do is to freeze the probability column here. Sorry, the row. I've done that because I want to copy the same formula into column I. So I want to make sure that the probability stays there, but this goes from x to y, that stays there. This should stay down at the bottom. So now I can just copy both of those things down to here somewhere. And if I sum those, just going to sum. Yeah. So this is, okay, you pause the video and say what it is, and it is the var of x and the var of y, because it's the expected value of the difference between the random variable and its mean squared, var of x and var of y. And then, so they show var, another column showing the product of those two things, how far x is from its own mean, how far y is from its own mean. Multiply those, multiply them by the probability, so sum it and you get the expected value of that. Across to here. That means that I. So x minus expected value, this minus that times p. So that's just a label. Now I've got to actually turn it to reality. So I'm going to go x, take away, where's it gone? The mean of x. Times brackets y, take away mean of y times the probability of that. No, come on there. Times the probability of that's just there. And that I can just leave free. Because it's not quite right. Because these two numbers should be the expected value. So when I whiz down to the bottom of the column, I've got they should be here and here. So I'm just going to correct it by moving that one to there and that one to there. So they should be these, subtracting the expected value each time. That's better. That's the bottom. Okay. And then sum that. So sum all that is 36.65675. So if you're following what's going on, can you say what that is? Okay, hopefully you paused and thought about it. That is now covariance of x and y. So this is the thing which is telling us something about how x and y are varying together. So this positive thing means there seems to be some kind of tendency that the bigger x gets, the bigger y gets. Okay, and now I said I wasn't going to go back to the other spreadsheet, but I think we should be copying this and in fact just seeing what happens with these variables here. Can you predict what's going to come out here? Because these variables are supposed to be independent. So if we add that, can't remember what happens there. We haven't got the variance covariance. Oh. Actually, we don't really care about that. Well, actually, we do. Yeah. Okay, let's get the whole thing. Getting behind on this one. So, first thing to notice is that the covariance is nothing. Okay. And that's because these are independents. So that verifies the thing before, and that's why expected value y times this comes out to be equal to that, because they're independent. That confirms that. Okay. So you find the covariance. Okay. Noting this can be a bit difficult. Adjust the probability distribution shown in the top table to increase or decrease the covariance of x, y. Okay, that can be quite hard, but okay, let's have a go at that, and then I'll have a go at that, and then make sure you reset it, and then we'll just see how you get on before we get on to the next video. So unfreeze this so you can see what's going up here, and let's reveal this stuff again. What I'm going to do is put a formula here, so it's 1 minus sum of all these and all these. So I'm replacing this with a sum and then just label it to make it stand out a bit. So don't change that one. We can change the others. So how do you want to increase the covariance a bit? Well, think about how you're going to do it and see if you can predict how you do it before you do it. And then, so pause the video and try that for a second. Okay, hopefully you thought about that. Just check what the covariance is. So it's currently 36.456. Let's just borrow that for a minute. So here's the covariance. I want to try and make this a bit bigger. So if I want to make it a bit bigger, I want to make sure that the high values of x and y go together. So if x is low, we're less likely to have high values of y. So if I decrease this down a bit, it automatically builds up this one, particularly this one here. And things like this one's going to take that down a bit. So you can see that that's taking away the likelihood that when x is getting high, you're making it less likely for y to be low. When x is low, you're making it less likely for y to be high. So you want to make it more likely that low values go together and high values go together. So increase these and build up the values there. So the more the higher probabilities are concentrated around this leading diagonal, the higher the covariance will tend to be. And sure enough, you can see it's gone up to 48.05. And then it's decreased, you just have to do the opposite and put a bit more fat into the corners here. Okay, let's make sure we go back to the original settings, which was like that. Okay. Yeah. So you can increase and decrease it just by adjusting the probability distribution. If you went to the other spreadsheet where they're independent, you could then spoil the independence by doing that. And reset the distribution to the original values before continuing, which we'll do in the next video. So I'll finish off this part of the demonstration in the next video. So for now, thanks for watching.